Okay, so this is a joint work between political science department and computer science department at University of Texas at Dallas. And this work is funded by National Science Foundation, National Security Agency, and Air Force in the past. And this is more applied work, so it's not a hardcore scientific contribution. So basically, we apply deep learning methods in the political science domain and demonstrate how it can benefit, the machine learning can benefit in political science domain. So outline of my talk, first I will talk about some of the problems that are related to the political science domain. So what we call it event coding in the political domains. So that problem I will introduce you first. Then I will talk about how that event coding problem can be extended in a multilingual setting, not only focusing on English, we can focus on Spanish, Arabic text. Those are the problems we try to solve. And then I will tell you that how this event coding problem can be extended or can be solved using transformer-based model, which Google developed, called BERT model, bidirectional decoder encoder, bidirectional encoder and decoder. So that we adopt here. So we'll talk about that. And we have some work here, extend the BERT in the political science domain, what I call it conflict BERT. And I had a very good student, PhD students, who just published a papers in top NLP conference called NACL, North American SEL. So in that conference, the last item, the last topic, conflict BERT, was accepted this year. It was he presented that in Seattle this year. So I'm going to cover those a little bit high level. And this work is going on for a while, and we have a bunch of collaborators from various universities in the US. So let me introduce you the problem. So the problem is we crawl a bunch of news articles from the web. Just think about Guardian, then New York Times, CNN.com. From there, we crawl various news articles, and then we try to make sure that those articles are related to political science domain. Then we try to extract the metadata. In this case, metadata will be machine-coded event data that I will explain in a minute. So let's say there is a conflict going on between Ukraine and Russia. So in this case, Russia attacked Ukraine, right? So the source will be Russian, and the target will be the Ukraine, and then certain conflict is going on. So we want to identify the source, target, and political actions. So that's our goal. And so in the political science domain, they heavily use for this event coding, they use the Cameo dictionary or Cameo format. In this case, the format is who did what to whom format. So who means you can think about, basically the goal here is to identify the source, target. There are two entities will be involved in the conflict. So our goal is to identify the source and target and the actions. What type of a conflict is it? So that we call it machine-coded event coding that we want to extract. And here is an example. Let's say this work heavily relies on the text processing. So just think about, this is English text where we talk about US Secretary of State wants to help Israel. So the source will be the US, and then the target will be the Israel, and then the action in this case is the verbal cooperation. So basically these two entities want to help each other. That's we already know. And then second text, or the second sentence, they're talking about, for that we want to identify the source, target, and action. The source will be the Irish nationalist guerrillas, and then the target is two British soldiers, and then in this case the action is the conflict. So the key point I'm trying to make here, we want to identify the source, target, and the action. So we will give you a bunch of, in this case, the problem setting is this. We have a bunch of articles, and each articles will consist of many sentences, and we will parse each sentence, and from there we try to extract this event coding or metadata, what we call it source, target, and action. And so the political scientists, they develop this ontology or taxonomy or hierarchical knowledge. They have the root, and under the root there are four children: verbal conflict, material conflict, verbal cooperation, material cooperation, and each of them will be further categorized and so on. So our goal when we talk about the action, so action will be, we want to assign action should choose one of this category. So this knowledge base is given, and we have the raw text. From there we want to identify the source, target, and the action, and action can be in one of this category. So there are around 20, or actually more than 20 categories. So we want to categorize those 20 categories. And now, before this, all this deep learning or machine learning, they try to use simple pattern matching, and the political scientists. So what they do, they crawl once we crawl those news articles, and after filtering, we have the political news articles. So we parse each of this sentence, and then from the sentence, we try to identify the verb, the action, and then with the help of Cameo dictionary, we try to determine whether the verb is identified, particular conflict or action, and then we use another dictionary which will have all the political actors. So now in Bangladesh, what are the political actors, do you think? Sheikh Hasina is one of them, Begum Khaleda Ji is another, and who else? And all these ministers, and these are all political actors. So they will appear here in this dictionary. So if they say Sheikh Hasina did this in the text, then after parsing the Sheikh Hasina keywords, this system should figure it out that Sheikh Hasina represents BD Gov. So that we want to extract here. So this actor dictionary will consist of all the political actors. Now keep in mind, in Afghanistan, where there is a conflict going on frequently, right? In Syria also, and the new political actors are emerging very frequently. Recently, the guy who just US killed him. So especially, so anyway, what I'm trying to say here, these political actors are evolving in Afghanistan setting. So in that case, usually the political scientists maintain this dictionary manually. So they construct this dictionary by hand, and they use it forever. Now, in a political domain, these political actors are evolving over time. So new political actors will come. So in that case, it might be tedious to update this dictionary very frequently. So this is one problem. Okay, so let me explain a little bit about the action dictionary. Action dictionary has after root, it has these four children. These are the two cooperation and two conflict, and each of them will be further categorized and so on. In our case, in the political science domain, they use the pattern dictionary. So they look for certain key verb with the help of a pattern dictionary, and then if there is a match, and then they look for certain other things, and that way they will say that this action is carried out, and then they try to match it with the actor dictionary, bunch of actors. And this is a big data problem that I don't want to explain too much. So here we crawl bunch of political news. This is our workflow diagram. So we crawl various political from New York Times or CNN.com or Guardian.com. From there, we crawl the articles, and then we filter out whether it is a political news or not. And then once it is a political news articles, then we parse it using Stanford Core NLP, and then extract all this parts of speech tagging, and then the name entities. So in this case, we utilize Spark framework to facilitate faster processing. And then we use bunch of political dictionaries, actor dictionaries, and then the verb dictionary to identify the political events. And from there we extract all this source, target, and action. And then also we do the location extraction, where the incident took place or event took place. And then we put it into the MongoDB for political scientists to do further analysis. So these are the old work we did, and these are the data sources we process, and data sources are very huge. And this is one of the sample. And now let's talk about some of the challenges we face. The challenge is when we parse the sentence and then we try to match it with the actor dictionary. We try to match it with the verb dictionary, Cameo verb dictionary, whether a certain action is taken place or not. So there is a possibility that it may not match with any of this verb. That's one possibility. If it doesn't match, then no event code will be generated. If there is a match, then we'll go to the next level. We'll try to match it with the political actors with the help of actor dictionary. Be up to date. So in that case, we may not find the source or target. But if we find source target, then only the event will be generated. But if one of them is missing, then no event will be generated with the Okay, so this is our old work and a little bit outdated work. So I will tell you how this we do update the new dictionary, political actor dictionary. So that work was done by my former student, whose name is Salam Sayed. He's undergrad from here, and he's a very good programmer. So now he's working in New Jersey in some startup. So here, okay, so there are two things you need. You need the verb dictionary and you need a political actor dictionary. And I said political actor dictionary is not up to date. And so our goal is to update this political actor dictionary. And here are the challenges when you process this use this political dictionary. The changes, political actors may come with the various names. So for example, former president, US president, has various names, Barack Obama, Barack Hussein. So in the text, it may come in various form, it can come. And then also political actor role may change. Now he's not a current president anymore. So he's a former president, and that will represent time frame, if I remember correctly, 2008 to 2016 time frame, right? Okay, so we want to, in the dictionary, we will keep the each of these political actors affiliation, which country it belongs to, and then the time frame and what role it plays. That information we want to keep it there. And then there are actors, political actors role may change over time. Former this guy, he was chief of army. He was basically, yeah, many people don't like him, but anyway. And okay, so the goal here is to now the problem I try to solve here is I want to update the political dictionary on semi-automated way. So what we do, we crawl various news articles, and one of the interesting point is this you know, this former president of the US, Trump, he was not originally in the dictionary. As a political actor, he was listed there as a businessman before the election. And I was talking about this work was done before he came into power, so around 2015. So that time frame, we crawl a lot of political news articles, and all these articles talks about, say, Trump during the election time with the Hillary Clinton and so on. And now when we found Trump and try to match it with the political dictionary or actor dictionary, it doesn't match. So no event will be generated, right? But using our name entity recognizer or extraction technique, we found that these entities, that Trump was mentioned many, many times. And now the idea here is in that, so window one means it covers, let's say, a number of, so window one means 1 week of data we crawl. Next week of data will be part of articles, will be window two and so on. So let's say here we have basically 8 weeks of data, and each of this box represents a news article text. And many articles talk about Trump, and so the Trump was frequently appearing in the text, and in this frequency of the Trump keep appearing very frequently. And whether it plays US elite or the US gov, something like this. So what happened in the various articles, when Trump was mentioned, Obama was mentioned, and at the same time, many cases, Russian, this Putin was mentioned. Now, idea here is, in our case, and in that case, we will recommend, based on this idea, we will recommend this Trump will have this one of this role. But these first two are correct, the last one is not correct. Okay, so this is our old work. Now I'm going to talk about some of the recent work. And this work was rejected in some of the top conferences, and eventually it was accepted this year in this conference. Anyway, so here we try to use some of the classical text processing techniques and apply it in political science domain. So the problem we try to use the bar developed at Google, I think in 2017, and is based on is a bidirectional encoder representation transformer, something like this. I couldn't remember exact. Bunch of encoders will be put one after another, stacked together, and we use BART model to the BART can be used for the classification purpose. So if I use BART for the classification purpose, then it can be used to identify the structure information like output classes or the code. But if I want to extract the span of the text, that I cannot do it using this classification problem. So BART can be used also for sequence leveling. If I use BART for sequence leveling, then it can be used, BART is used for the span of text. Let's say this is the raw text, and our goal is to identify the action. So what is the, I cannot say source will be Obama. I will say source will be the UGov and so on. So when you use BART to do the two tasks, one task will do the multi-class classification, the other task will be the leveling. So in that case, if I use the multi-class classification, using that we can identify the action or the conflict. In this case, it will identify, it will label this this sentence as a verbal conflict, and then we try to identify the source and target. So in this case, the sequence level using BART will tell you that the who is Obama and the target is the Israel. Then our ultimate goal is to assign this type of label. So for that, we are going to use the Cameo dictionary and identify from dictionary that Obama is a US gov and label it that way. Now, that's the task we did, what we call it, BART extended to facilitate multitask learning. And we experiment on this data set. So it has a English text and the Spanish text. And for non-English text processing, we use UD. There are certain other tools we need to use called UPatrack. And okay, so we tested on the Spanish, English, Spanish, and Portuguese text. And here are some of the results. I don't know whether you can see it, but I cannot see that well. Okay, this column represents the source. In the source, what is the F1 score? And you know that F1 score is, what is the F1 score? It's simple harmonic mean operation and recall, right? So in the case of English text, we have this, and these are all baselines. So Petrack is a political scientist, use that. Basically, is a simple pattern matching. And then UPatrack works for the multilingual setting. And then LSTM is what is LSTM? Huh? Okay, so is one variations of RNN, right? So yeah, so that's another. And then the last one is our model, which is based on the BART. And you can see our model is doing better. So for the target, we have the similar result. And then, so this case, we report the result in terms of the source, target, and here we report the result in terms of the verb, action detection. And each case, our model is doing reasonable performance. And then here we try to show you the cross-language experiment. So in this part, we do the and test in English. And in this case, I think we train it in English and Spanish and then test it on the English text. And this case you can see here, we train it with the English text and test it on the Spanish and so on. And you can see our method is doing reasonably well. Okay, so now I have to talk about a little bit more interesting problem. Is also based on the bird. So the problem setting is slightly different. So you have this text, and from there we want to extract the political actors, is the P, political actors from the given text. We want to identify the location and the role the political actor plays. So for example, if I have a text that talks about former President George W. Bush attack Iraq. So in that case, George W. Bush is the political actor, and the location may be the US, and the role will be the US elite, because he's not in power anymore, let's say, for example. And this guy, Abdul Qadir Fitarat, he is from Afghanistan. I think he's a political actor, and the location is Afghanistan, and the role will be the Afghan government. What is the business? Okay, businessman, and so on. So our goal is to, given text, once we parse those sentences, we want to extract the information like this. And the political actor roles we have, these are the entries we have under the government. We have, I think, 13 categories, finer grain categories. So we want to find those. So again, the problem setting is slightly different. We crawl various articles, and we parse each sentence. And if the sentence has a political actor and location, we want to identify the roles of that political actor. So this is a two-step framework. And here we use, okay, so first we crawl various news articles, and then we try to extract the name entities and the locations. So these are the political candidate actors, and then the country's information will be extracted. Now, let's say Hasina is going to meet with Modi. Now we know that Hasina represents Bangladesh and Modi represents India, right? So now, in this case, in our approach, there will be a Cartesian product, will be Hasina, and then in the same text, these two countries will be mentioned. Let's say Hasina, Prime Minister of Bangladesh, is going to meet Modi in India. So in that case, there are two mentioned, Bangladesh and India, and Hasina and Modi, right? So in that case, the Hasina will have two possible countries with regard to computer. It will be associated with the Bangladesh and India, and Modi will be also have India and Bangladesh. So in that case, we need to identify which one will be associated with whom. So for that, what we call it a relationship extraction. Given the set of persons and the location extracted in the first steps, we want to learn semantic relationship for each person and the location pair. So it can be done through the zero-shot learning or distance supervised learning. So I'll talk about that in a minute. So distance supervised approach, I will tell you first, and then I will talk about the zero-shot learning. Zero-shot learning is a new concept in the deep learning area. So we try to mimic that idea here. So for every entry, the political actor and the location, in this, once we found, there are now multiple possibilities. The first possibility is the actor and the dictionary we found, that can we figured out that can be found in our Cameo dictionary. If it is found, then the problem is solved. We don't need to worry about it. So for example, if I have a text like this, so here we talk about this is one of the person, and this is the location, geographic location Azerbaijan, and then this is location, and then this is the another person, right? So we have 2 person and 2 locations, and so the step 1 will produce this. It will produce this guy with Azerbaijan, this guy with Austria, and this guy with Azerbaijan, and so on. So Cartesian product will produce total 4, but 2 of them are relevant, 2 of them are not. So if you're lucky, you can find both entries in this Cameo dictionary, then these 2 are not relevant, you are done, right? But there is a possibility that actor is found and no semantic, but no affiliation with the location. So in that case, what will happen? So in that case, we will assign something like this. So this guy with the Austria, it will be nothing. And this information will be very useful for the training purpose. So as I said, we identify the name, political name or actor, and the locations. And now the name and the location can be found, both of them can be found in the dictionary, then the problem is solved. If it is not, if the actor is found in the dictionary but not affiliated with the country, then I can say that this information, what I extracted here in the step 1 is not a correct one, and that information will be used for training. And the third case, actor may not be found also in the dictionary. So in that case, we can use it as a test data or inference problem. And in this case, you can see here, if I have a text like this, US Senator blah blah blah, and so in that case, somebody so in that case, if this entry is found, US go, and then this. Okay, so if let's say in a step 2, we found this in the Cameo dictionary, we found this, but we can't find this with the new work in the Cameo dictionary. So therefore, we will assign it with the help of Cameo dictionary. Now how the distance supervised learning will work, will fed into the BART model. And as I told you, BART has a bunch of, they use, I think, for the regular one, they use 8 encoder, right? So, and then here we will have will fed into the network. So the first one is the CLS token, then the persons, and then actor, and then the location. So these are the vector will be fed into this network. And then here we try to extract, so it's a bunch of encoders. So in this case, the last layer will be the also output layer will be the encoder. This person's encoder information will be extracted, and this will be extracted and then concatenated. And then we will use fully connected layer, and from there we will predict the output probability, which is softmax. So then what will happen? So as I told you that this case, this will be the input. Sorry. This will be the input to this network, and then using this in model, and then here we will it will generate some sort of vector representation or embedding, and from there we'll concatenate those embedding and convert it into probability and so on. And this case it will produce what? It will produce the test case. If I give a input will be a person, and the location information will be fed into the network, and it will be converted into embedding, and then it will produce some output, and output will tell you that whether it is a whether it represents a particular country or what type of okay. So I'm sorry, what it will represent. It will represent one of this. Where is it? Okay, so it will represent one of these categories. So if you remember this under GOB, we have GOB business, GOB lab. So one of these categories will be predicted. So that's the distance supervised learning we utilize here. So do you have any questions so far? Yeah.
When same type of people appear in a document, then a person who's role we don't know, we just set the role to the role of those persons. But if a new political actor comes in who is more frequently just say dashes the other government, say a political US running mate who is actually just bashing the Russian government frequently.
Right.
Then
yeah, so in that case, yeah, this method will not work that well. So it may recommend that this guy is playing the Russian government role. So that's a problem, because we don't try to understand the text. We just try to do simple matching or something. So in that case, yeah, this is a shallow approach. So we may need to use some more we need to understand the text better, and then we can assign the roles. The problem with that type of approach, usually when you try to understand the computationally expensive and always challenging, because the text is always ambiguous. It has the keyword keyword depends on the particular keyword depends on the context also. If I say bank, I'm going to the bank, that means I'm to withdraw money. That means I'm going to the financial institution. But if I say I'm going to the river bank, that means for enjoy my vacation. So that means I'm going to the close to the river or something. So in that case, it's nothing with the financial institution. So it depends how you use the words. Yeah. So I'm aware of the first work. First work was not the great work. We just started at that time and we did some very basic work. Now I think the work we are doing is interesting and more challenging. So let me tell you a little bit about the zero-shot approach. And here we utilize the language and natural language inference model. So put two text sequences. We will have a premise and hypothesis. The model will output one of the three outcomes: entailment, contradiction, and the neutral. Entailment and neutral means hypothesis neither follows nor the contradicts the premise. So here is a text, and this is the premise, and this is the hypothesis. And now, did I say wrong? Okay, so goal here, given a text. Okay, so given a text, we will from there we generate the premise, and then from there we come up with the hypothesis, and then we try to say that the hypothesis will have the category called one of the three groups: entanglement and neutral or contradiction. So for the hypothesis generation, we use dynamic hypothesis. So for example, here these are the hypotheses we use. So the government agriculture means the P is the part of agriculture, L is the location, and P is the person. Remember, we have a raw text and we extract the person name and the location, right? And from there we try to generate this type of hypothesis. And if P is a part of, if the text talks about something in the agriculture, then we can say that hypothesis may be this, and so on. So this way, we don't care about original person name that much. As long as these are the important keywords that appear there, that is the most important one. So for example, if I have a text like this, and hypothesis, the premise will generate something. So okay, the pair will be generated like this, and from there we try to generate the 13 dynamic hypothesis, and then our goal is to predict which hypothesis this should have. One of them will be true. So, we will have. So we will fit into this BERT model. So Roberto is the lightweight of the BERT model. So it's similar to BERT, but it is a little bit lightweight. It works. It doesn't need that much training and so on. So here we fit into this in our network, and then this then this layer will predict one of the outcome, whether the dynamic hypothesis will have this entanglement and then a contradiction or neutral. So one of these we try to predict. And for our experiment, we use these are the data set. We focus on Africa, Latin America, all sorts of countries, and then these are the political roles, and then their number of cases we use. And now when we report the result, we report the results in terms of the recall. And now we say that it is correct only if the actor and the country were correctly retrieved. If the actor or political role were correctly retrieved, that's one possibility. And then when the actor and the whole role code were correctly retrieved. So, and then this is one of the baselines. So what we observe here, so when we try to retrieve all sorts of things that are political actor locations and roles, and this is the zero-shot approach, our approach, and the distance learning and the baseline. So you can see here our method is being better. So this air is for Afghanistan. And what we observed that at the time the student tried to do with all these gangsters, data sets, organized crime from Mexico and South America. So these are the groups there that do all this violence. So using our tool, we can extract various types of crimes and so on. And then, so then I want to briefly talk about two more things. One is that the paper was accepted in top conference, and this is one of the work I want to tell you. And this is interesting work, and it may have a future impact. So what we do, we develop a conflict word. Basically, we extend the word for the political domain. How? Okay, so before going to talk about that, I want to motivate you. The pre-trained language model that is trained on a very large scale unlabeled text, and our goal is to analyze conflicts and bias in political science, which are very challenging because due to the specialized language they use and lack of label data in that domain. And so now there are two ways you can extend the word. One is you can use the original word and then use the original word for our problem setting. That's one way. Another way is original word was trained on the very generic corpus. So now it is when you try to do the downstream task, do some classification or question and answering using word for the political science domain, it may not work very well. So use the domain corpus, and using that domain corpus, we will take the BART model from the scratch. So that we call it pre-trained from the scratch. So BART will be trained from the only the political science text. So usually the BART is trained in a generic text, all sorts of text. That's the Google developed. But we are not relying on that part because that is trained only for the generic data. Now, if I want to use that model to do the task classification for the political science, it may not work very well. That I will demonstrate. What we do, we use all the political news articles from the web. We download and build a big corpus, and then train the part on that. So that we call it free. And there is a I just want to check. I know you're not from political science department, but it's from Syria, right? Right. I see. Yeah. Syrian people call it that. So, but they divide this. You break the words like this, then. Letter downstream task. Related to political science domain, but when you so this case, so new domain, Tomato is the general domain of corpus they use, and word was developed. This is the it was developed from the use learning and so on. Okay, so we use new government and we use 7 like and we train the part from the another one on we continuous pre-training model, and here we show the complexity, we try to say, and then for evaluation, these are the data set from the testing. We use the protest data set, and is the testable publication downstream class, and GTD is a terrorism class classification. And these are the things we did here. And these are the metrics we do. And what say on that case means and continuous that means from the scratch. And you can see our model is being developed across all these data. And so these are mostly the classification problem. So that shows that when we use a word, you can achieve good accuracy or good performance, but using the complete word or domain specific word, you can achieve better performance. And another thing that when we very limited data set, then our approach is being better than the word. The more data you will use, the traditional part will be as good as the our. So that's the first one. And now let's talk about. Do you have any questions on this? Now we'll talk about level 10 more minutes. And now, do you have any questions? Yeah. Yeah, it's a very good question. I think overall, it depends upon what type of task you want to do. If you want to do a very specific task tailored to the political science problem, then our conflict word that is trained from the scratch will do better. And in future, we want to do the question and answering type of things. So there, the conflict word will do better with the that is trained from the scratch. Because one of the problem with you are giving very targeted knowledge to the encoder to the training during the training time. But if you use the conflict word with the continuous training, that was basically we try to modify the pre-training word model. So in that case, there is a possibility that you may have some those generic knowledge can be transferred here. So what they call it catastrophic forgetting. So this is a classical problem in the data. With the new knowledge, it may forget the old knowledge of things. So these are the problems that exist. They rely we call from BBC, CNN, not from Fox News. So in that case, yeah, in that case, we can say that at least it is not a fake news because we don't focus on the Twitter and all. And you know that in Twitter, people can spread the fake news and Facebook. We haven't tried those, so we can say that concept. And here we don't But that might be also, there might be some bias. Russian can say that we rely on the Western media, not the Russian outlet. There might be some bias, but it's not that bad. Any other questions? What is the last?
The biases of the newspaper, the news that it possesses, actually transfer with the more strict way.
You mean the bias? Yeah, let's say if the nowadays CNN doesn't like Trump at all. So in that case, yeah. But we are not going to that much details. We are just trying to identify the source, target, and action. So it's slightly different and so in that case, but if you say that, and we're not talking about the fake news because we're relying on the authentic sources. At least the articles are authentic. There might be some inherent bias, but that type of bias we're not focusing on.
These are what we to classification of
The forecast I'm going to talk about. I'll tell you now. Concrete word will do better or will as effective as word or will do better. The way we design the task, that will concrete word will always outperform or will be as good as the word. But if you come up with the generic queries or generic problems or tasks, then word may do well. It depends on the problem setting. Okay, so here I'll tell you some of our forecasting work. This will be useful for the social science. And this work was done by Ifan Lee. Yes, okay. So accurate violence forecasting is important because that there will be a political crisis will be going on. Then you can send some troops to stop fighting or fatalities and so on. And even this work can be used. COVID-19 predict that COVID-19 actually doesn't. I tried our model, but it doesn't work. And traffic is speed on highway and etc. and so on. Okay, so let me motivate you with the problem setting. So this is let's say we deploy a bunch of sensors in various places in the campus. So let's say in this is called West Side. Right? When I was a student, this part was not here. I mean, no building was here. So what is that side? This side. Okay. So we have to deploy a bunch of sensors, and each sensor will give you the readings. So in this case, it shows you the AJM. What is the variable speed? So the higher the number means the traffic is moving fast, and so on. And so let's say this sensor 1 and sensor 2 are geographically next to each other. So if there is a delay here, what do you expect? And then next, within the next second or next 5 seconds, the delay will be high also here, right? Level speed will be very low. So that type of dependency we want to capture. So okay, so that's the spatial dependency, but here we're showing the temporal relation. And so goal here is we have the spatial temporal data. From there we want to predict we want to do some sort of forecasting or prediction. So it can be used to predict the traffic delay or average speed at a certain locations. And in Africa, what they do, they divide the Africa into three cells, and each cell represents a particular geographic location. There is a fight going on in the past due to the natural resource. And if there is in this area there is a fight going on, and if there is a road there, so there is another location here nearby. So what do you expect? If the fight is going on here and people are dying, there will probably there's another fight going on here also. So not fight. Let's say there is a famine going on in this region, and neighboring cells will have also dropped. Africa per cell, and they capture this data over 4 years. So the whole Africa will be divided into a number of depth, and it has a temporal aspect as well as the spatial aspect. And this problem, spatial temporal problem, can be used for the traffic network delay prediction, forecast, and wireless early warning system. This data set was released by some researcher from Sweden. Okay, so it is actually the spatial dependency is the grid locations, and then the temporal aspect is the monthly record. I think they have at least 5 years of that. And so we want to do the prediction for this data set. So the prediction is like this. So I will say, why don't you tell me next 3 months how many deaths will happen at each grid of this map? Next 3 months, how many deaths will happen? How many deaths will happen? That we want to predict. So what do you expect? It will depend for that particular location. We want to predict how many people will die. It will be based on surrounding locations will have influence. Past previous time series data will have influence. So that we need to capture. So what we use traditionally, you can use the spatial dependency and temporal dependency to do the prediction. There is a classical math model electrical engineers use called ELMO model, or control theory guy use that. It's a very simple model. Just take a moving average. So here we try to use the deep learning technique, what we call it graph neural network. So in case of Africa, you can think about each grid or each cell will be represented as a node. And what will be in the graph? What do you have? You have the node and the edges. How do you represent the edges? Each node will have an edge surrounding, neighboring cell will be the edge surrounding location. based on this use. In our case, we try to use the GNN, but that will capture both spatial dependency and the temporal dependency. And how we capture the temporal dependency, that I will explain in a minute. Okay, so in our framework, we do some sampling and aggregation to facilitate spatial and temporal dependency. Sample module will construct a heterogeneous subgraph, which includes both spatial and the temporal relationship. An aggregate module will investigate how to aggregate heterogeneous information together. Okay, here how we construct the graph. So first we connect the spatial neighborhoods, then we connect the direct timestamp. So with the same graph, we want to represent, usually the graph is useful to represent the spatial dependency. Here, we try to use the graph to represent spatial and the temporal dependency together simultaneously. So that can be done through these steps. Spatial neighborhood will be constructed, then spatial direct timestamp will be represented. Then Yeah, that's a very good question. With regard to your first question, political conflict or catalysis depends on various variables, right? Not only 2, 3 variables. So the graph neural network I showed you, each node will have a certain inherent characteristics. So they will have their own features, each of this node, that you can embed in the graph neural network. That's the beauty of the graph neural network. So that way you can say that it can consider those features. That's the power of the graph neural network we observe. And I think it will be very suitable for the social science studies. And with regard to COVID-19, we try to predict first within US. Within the US, each state, how many deaths will happen, or how many hospitalization, or how many cases will happen in the next 1 week, or we try to predict. And well, the problem is we observe in case of COVID, let's say if there is a because if you are bordering, say, as long as if you have a China, Shanghai, Beijing to us, then there's a problem. So that we observe. Because the COVID spreads China first, like those international